I am going to give presentation about my project, Fertilizer Recommendation System for Disease Prediction. Myself, G. Venkata Srinivas. I am from Computer Science Department, and my teammates are G. Venkatasai, T. Teja, and Akshay Krishna. Coming to the problem statement, customer segment. The farmers are the main and prime customers of this project, and job to be done are problems. Detection and recognition of plant diseases using machine learning are very efficient, providing symptoms of identifying diseases at its early stage. Applications of computer vision and image processing strategies simply assist farmers in all of the regions of agriculture. Triggers helping the farmers to take a precise decision on fertilizer for the curing of diseases in crop and plant with the help of automated analysis, which the project is based on. Emotions. It helps farmers to take a precise decision on fertilizer and increase their yield and productivity of crops. Problems root causes. Generally, the plant diseases are caused by abnormal psychological functionalities of plants. Therefore, the characteristic symptoms are generated based on the differentiates between normal psychological functionalities and abnormal psychological functionalities of plants. Most of the plant live diseases are caused by pathogens which are positioned of the stem of the plants. So, the solutions. The system is built with use this model. The systems that provide fertilizer recommendation based on the prediction and diagnosis of the leaf diseases, which are depending on the segmentation, such as segmenting the healthy tissues from the diseased tissues of leaves. Behavior easy to use, can be able to respond quickly, able to provide precise decision on the disease analysis. Just the requirements are internet speed. Channels of the behavior. The farmers are need to access the system and offline. Store the data and information being transformed. On going to proposed solutions. The problem to be solved is it is difficult to identify the problem with the crops at every stage. So the idea is by uploading or taking the pictures of affected plant, it analyzes with the reference picture available and provided all information about the diseases of the plant that is affected is given in the database. Uniqueness. As soon as the farmer identify the difference in their plant, they can take closer picture of the particular area in the plant and quickly find a problem with their plant. So it is easy to detect or analyze the situation. And the social impact is at early stage it helps farmers to save the crops before it fully affected, which is a major profit of this model. And the business model is the company can charge fee to access the application for more than three such information per day. It even helps both the farmer side and for the revenue model of the business. And the scalability of the solution is subscription of the application can give multiple access and more information to the farmers. When it comes to technical architecture, the model is trained by giving the information input as input 1, input 2, an image, and input 3. And by taking this information, it is tested. And by testing by number of times using SVM, supervised machine learning, it is evolved. And when the farmer or customer gives information, when the information to the model, it is predicted using the natural language process. So when the administrator or farmer log in using user interface, the input will be analyzed by natural language process and the required information will be delivered. So working demo, we are demonstrating the developed model which is successfully tested and performed in IBM Cloud with the help of Watson Studios. We are going to there. Here, this is the project which we done in IBM Watson Studios. Here we tested. In this code line, it is clear we are installing the Keras and TensorFlow, which is required for the process for the project, and all the it is showing the requirement and already satisfied, which we run multiple times for testing. After that, the image augmentation is taking place for TensorFlow Keras processing image and importing the image data generator. Here, by giving the range, we train the data generation with the images, and we test the data generated with the image generator process. And when we will upload the data set here by using this. After that we insert the code streaming body object to this code here automatically it will be uploaded, and the API key and the required endpoint token, everything will be auto assessed by the Watson Studio. Then when we go to downstream, here here in this line, we all trained and given the indexes and more number of tests given to this model. We will train the model by accessing the data set in which how many cluster it has, many files, etc., etc. Then when we go to the CNN model, it is the model is added, evaluated, evolved by using more number of test cases, runtime measures, etc., etc. And output will be given like this. And then when we come to the saving model, the planned dataset is saved and model is saved as fruit.h file, which we have used to train this model. And everything will be saved in the document. When we come to the IBM cloud deployment, everything is automatic. Some requirements such as Watson machine learning clients are required necessary for this project, and which is successfully installed. And when we come to here, it is automatically generated API key, which we have done earlier. And these credentials are saved as API client. Here, the client or software specifications list will be automatically installed for the further process. And when we come here, the planned project dataset train model is automatically saved by training the model more number of times. And then here by testing the model, we imported the data here we imported the data plain dog dot test apple scap leaf, and the images and the output will be given like this. After the output, this image will be transformed into arrays, image to array, and this arrays will be crisscrossed by model number. If this array is same, if the given picture and the dataset picture were matches, if the arrays when the picture is converted into array of the given plant and the dataset plant, if they are equal, then then the model will reply as it is identified, and the plant has the disease. So then it intimates the farmer that it has problem, or if it is not, then the model will be replied as peach is a healthy. It will be given like that. If when the in other sense, when we upload the picture will be, I mean, image will be converted into array. Then the image which is in data set having the name or having that set name as infections or diseases to the plant. If that array is matches to the array which is given by the farmer, then the model will be assist to farmer that the plant has a proper disease, and for that disease, farmers should be use the required or recommended disease. Thus, it will help. Thus, it will help the farmer to recognize the disease. So, this is the performing matters. When we import that image, the image will be given like this. And future scope. The proposed model in this project what can be extended to the image recognition. The entire model can be converted into application software using Python to exe software. It can be used for both Android versions or even for the computer software. The real-time image classification, image recognition, and video processing are possible with the help of OpenCV Python library. This project work can be extended for the security applications such as figure print recognition, iris recognition, and face recognition.